So now that we've gone through the PowerPoint for 7.3, what I want you to do in the activity is to first identify the different types of tolerances that you see on this drawing, and they want you to do it using a letter, right? So I can place a letter next to this, identify the type of tolerance this is. This would be limit dimensions, and write down what the total tolerance is. So the difference between the upper limit and the lower limit is going to be our tolerance. So there's several on this page. I'm going to identify all these by letter. Do the same thing here. Identify the different types of tolerances by letter. I believe total there are 10 if you're not including the general notes. Then we're going to do some calculations using this rod and the drawings above to determine things like what the tolerance is, what the length of the rod, and other types of information here, along with the 3 conclusion questions. The second half of this, what I'd like you to do is to take 2 parts from your reverse engineering project, and specifically 2 parts that actually connect together. So they have to fit together, one fits beside the other one, so on and so forth. And those 2 parts we're going to do drawings on title blocks, add the dimensions to those drawings, and then add tolerances on where those 2 pieces connect. So let me show you an example. For mine, I'm going to use the trammel toy that we built, and I'm going to use one of the base socket head cap screws and one of the corner guide blocks that connect together. Okay, so on the drawing sheet, sheet number 1, I did the corner guide block. I added all of the dimensions on here, everything that I would need for someone to be able to recreate that. I added the center lines and all that information. I did the same thing for the head socket cap screw. Added all the dimensions on here, added the center lines. Now what I want to do is go back and change the tolerances. Okay, so let's think about the tolerances for these 2 pieces. Where do you think it's going to be critical for the connection between these 2 pieces? If I'm looking at this, the overall diameter here, the 0.25, has to fit inside the hole here. And if I'm looking at the diameter here, that distance is also 0.25. They're exactly the same size. Again, in Inventor, it would easily allow us to connect the 2, but in the real world, one of these is probably going to have to be bigger, while the other one's going to have to be a little bit smaller, especially if we want a clearance fit. So how do we make those changes? If I go back into the dimension, I'm going to make the diameter of this a little bit larger. I'm going to say that my target number is going to be the 0.25, but I want to make a unilateral tolerance where that it can be larger than the 0.25 but not any smaller than that. So I'm double clicking on that dimension. I'm going to go into the precision and tolerances. Then I'm going to select which number that I'm wanting to change. So am I talking about the diameter of the part? Am I talking about the depth of that counterbore? What it is that I'm trying to fix? So I want to look at the tolerances for the diameter of the holes. Now, here's the thing that's a little bit confusing in Inventor. They don't use unilateral, bilateral, or limit dimensions. They use stacked, which is basically the 2 numbers on top of each other, symmetric, which would be bilateral, I mean same on both sides, and then deviation. And that's the one that we want. We want a deviation where the lower limit stays 0 and the upper limit, and this number is going to be a complete guess on my part. I don't know what the actual tolerance is in that part, right? But I'm just going to guess that it's that. And then I'll hit OK and OK here. So notice now I have my target number, 0.25. Can't be any smaller than 0.25, but it can be larger by 0.02. Now, if I go to the other sheet, I'm going to do the opposite, right? If I know that this is 0.25, I want this to be smaller than that, right? And I don't want to get any larger than 0.25. So if I double click on this dimension, go into precision and tolerances, I'm going to do the same thing. I'm going to do a deviation. I want my upper limit to stay 0 and my lower limit now to be 0.02. Again, the number itself is not critical. I don't know what the actual tolerance is in this part because I'm not the manufacturer, so I'm just kind of throwing numbers out there, which you will do as well. And hit OK. So again, now I have a target number. It can't be any larger than that, but it can get smaller. What I'd like you to do for this activity is to try the different types of tolerances out. Right? So maybe I want to add, I don't want this to be that exact number or guided by a general tolerance. I'm going to do maybe stacked. So that maybe the top number is 1.9, the bottom number is 1.6. So now I have a limit dimension where I have the two numbers stacked. And then I could do the same process for the other holes using a bilateral tolerance. Okay, so the goal for this activity is to take two of the parts that you actually used in your reverse engineering project that physically connect together, start changing the tolerances of the parts that actually connect, or the pieces that really matter. Because if I look at this, does the overall length matter when it comes to whether or not the screw is going to fit inside this piece? No. The holes where the screw goes in are going to matter, and that's where we're going to add the tolerances. Last thing I want you guys to do is to add a general note to the page, or like a general tolerance. And again, the numbers we use here are going to be pretty much made up. In fact, if you want to use the numbers that were in the PowerPoint, that works for me as well. So let's say that for my general tolerance for all dimensions, anything that has one decimal place, I can use symbols in here, is going to be equal to plus or minus 0.020. And if it has two decimal places, it's going to be 0.01. And then finally, three decimal places, it's going to be 0.005. So this would be kind of like a general note that goes on my title block. I can add this to both pages if I'd like. So that I have the same information on both pages. And when I'm done with the general tolerance along with all of the individual or specific tolerances, I want you to save these sheets as a PDF to be submitted on the LMS along with the 7.3 Word document. Keep in mind that because there are more than one sheet for this, when I go to PDF, I need to check the options as well and make sure that I'm including all sheets within this drawing. Once this PDF is generated, upload this on the LMS and you will be done with this activity.